All right, so I'm live with 52 weeks of exploring interesting languages. I'm on Julia here, and in particular, I am going through and going to talk about the types a little bit. So I'll go ahead and share my screen here and make this a little bit better. So one of the things I'm actually discovering that's kind of a cool concept is that GitHub code spaces um, is actually able to integrate with Copilot. And so what I haven't done yet with Julia is to use an AI assistant to help me write code. And so one of the things I think I'll do is try to be a little more proactive in trying to not just do the interpreter in Julia, but also to write some Julia code so that I can get help basically from the AI assistant here. And so let's first take a look. If I go to extensions and see, see, I don't have it loaded here. So I'm going to go ahead and load up Copilot. This. And this one, now it's interesting the difference between Copilot nightly versus Copilot. I have to admit, if it's a new language, I would almost be a little bit tempted to do the nightly, but I'm going to do the traditional one here, and we'll stay with that for now. But this could be like a game changer for me, right? Because look, GitHub Copilot, we can see here some of the things that are happening, and I guess I could even configure this thing, and we could look at the change log and see, what kind of fixes have been added, and other things inside of here. But basically, now that I've got this thing enabled right here, then I should be able to play around a little bit more with other things inside my project. So I'm gonna experiment, I guess. So let's go ahead and say touch Julia types, and then we'll do this. And then if I just go down to the manual and get into types here, and let's try this. Like let's just do a little bit of experimentation with types. And if I go back to my document right here, and I put in some stuff here, let's see what happens. Does Copilot come in? So yeah, maybe Copilot is not our friend here. It doesn't appear to be giving me any suggestions. I guess I could look. I could say GitHub Copilot Julia. So it may just be too obscure to train it out and seeing if there's any information. I don't see anything yet. Trying out GitHub Copilot. I made a couple repos with this. Don't run that. It's a bad joke. Is it working better for, let's see. So I see it supports Julia. Wow. Okay. So according to this, it does support Julia. And I guess I'll do this. I'll put a, we'll put some documentation here. I always forget which language, when you keep switching between different languages, which language has which comment structure. I guess I could be lazy and just say comments Julia, which style is supported. We can do that. What else? Comments, Julia comments. I guess I could say comments. What are all the styles of comments here? Julia comment styles. And I don't really see. It's surprisingly difficult to find, but I guess I can do this. I can say this is a comment and run it. Huh. Well, so now I see some auto completion. And so now if I say Julia-Types, there we go. So we see that it's able to run code that nothing's happening, right? So that's good. But now what if I want to play around with types here? And let's try something like this. Let's see what happens if I build a function. There we go. So we have an x here, function foo, and we say 100 like this. And then what's it going to ask me to do? It's going to say y. Okay, so yeah, I'm seeing some good stuff here. So it says y is equal to int a y of int 8. And so we're basically just going to make some kind of play function here. What's the next line going to be suggested? I'm assuming we could say z here. We could do another one, and we could say return z. There we go. I like this. So basically, it's giving me some good ideas for how to write things, and then I guess I would just do a foo here. That's right. Wouldn't I just do print foo, or zz is equal to foo, and then print zz. Does that work? Print zz. Or actually, let's try it out. Let's see if Copilot will say print results of foo, and let's see if it does it. Oh, there you go. I like it. I mean, it's pretty crazy because if I put a comment, then it will interpret my English. I believe, just because I've played around recently with OpenAI, is that it'll tell me, it's essentially prompting the code generator what to do next. So if we go up here, oh, not bad. Print the results of, now let's try this. Let's try this. So let's say print the result of foo with a new line. Aha. Now what happens? Now why is it not, there we go. Aha. So you have to just kind of, I think a tab, or I don't know how you prompt it, or it just takes a little bit of time. So if I go here, there we go. It just gives me that. There we go. We'll save that. Whoa. Okay. Well, this, I could see how this could be kind of addictive in terms of learning a language. And I wonder if I could learn a language like 100 times faster. I'm starting to think I might be able to. So, like prints all Julia-Types. Let's try that. Okay, well, that's not exactly what I wanted, but if I go through here and see, it prints, how about print the Julia type? There we go. See? So this is pretty cool, of foo. There you go. Print the Julia type of foo. So basically it showed me the built-in function type of that I could use that. So the first one prints foo, and the second one prints the type of foo. So I could basically use my AI tool plus the documentation to kind of supercharge things a little bit, which is actually very interesting. So let's see what's next here. This declaration behavior only occurs in specific contexts. Declarations can also be attached to function definitions. I see. So you can define that the function is a float 34. So returning from this function behaves like an assignment to a variable. The value is always converted to float 64. Pretty interesting concept. That's a new one for me. To basically append a type to the return value of a function by declaring it with the function definition. Definitely pretty interesting. So let's try this. Let's say we'll call this declaration attached to function. Declaration attached to a function. And then I'm going to paste this in. And then we want to print the results. Yeah, that's exactly what I'd like to do. Thank you. Print it out. And then we can go here. I mean, this might be the future here of learning to code, because why would I use the interpreter if I could just use AI to tell me what to do? And so in this case, we see that's the return value. But let's say I also want to print the Julia. Well, you're reading my mind. That's exactly what I wanted to do. I want to print the type next here of what's happening. And so there we go. Thank you for reading my mind. It's almost uncanny. It's creepy almost. There we go. Float 64. So I think I'm going to be a lot better at Julia very quickly now. So abstract types cannot be instantiated. Not that interested in all that fancy stuff. Operator is a subtype of, sounds good. Primitive types, it's always preferable to wrap in a new composite type. Composite types here. So composite type are record structs or objects in various languages. So in this case, you would do a struct that would have basically an integer and a float 64 inside. So let's do that. Let's play around with this. So we'll build another one, and we'll say creating a struct with multiple types inside. So we'll do that. So we have a struct foo with a bar int, and then we could create a new foo struct instance. And thank you. I like your suggestion. And then we can say print the results of foo bar. Yes, do that. Thank you. Wow, this is very interesting. So it failed here though, because let's see what happens. So we have a struct, this is correct, that has the type integer, type float 64. We then created a new foo struct instance. Foo is equal to foo, bar is equal to hello, print the results of foo bar. So yeah, why did that not work? Let's read the documentation. No method matching foo. Really? How is that no method matching foo? Closest candidates are got unsupported keywords. Well, what happens if we just print the actual object of the foo object? Print the results of the foo object. Let's see what they give me here. Is that how you do it? Let's try it out. Create a new instance, a struct. Yeah, so there must be a new way of, how do you print a struct? That's what we got to figure out here. Print struct Julia. You can overload. So we have a struct right here, base show. Base.show. So I guess it wasn't smart enough to show me that. But let's see if it can figure this out. So we can say base show print IO print line P. Okay, well, let's try this out. So let's try the let's do this. what did they call this? Oh, custom printing of struct. So let's have our AI tool here say custom print function for foo structs. Let's see here. Function print foo print custom. Let's do this. Let's say custom print function using base show for foo. I don't think that's exactly what I want. So base show, and you would do object my type. It's a lot of work that I don't want to. I don't want to type all that out, but I guess I have to. I have to do something like this, and base show, and we would do print foo, and in this case, if I go back here, it's IO and I see IO and points. And so this one would be foo. And then so print foo. What happens if will it be smart enough to just figure out the rest of this? See if it's see if that works. No methods matching foo. Again, I gotta go back to my I gotta do like a what is this? X is equal $ P of X, P of Y. X is equal to $ P of X. X is equal to $ P of X. I'm not sure I totally understand that. This is definitely an advanced topic that I'm failing at. Well, in a nutshell, it's a. I'll just do this. We'll just say, like, save for later. I'm too newbie to really do something that advanced, but I can say, a good project for me to test the type system or for structs and print them out. There you go. So that's a good one, and I can even say like to do, add a to do here. Do something like this in the future. That way, I can come back to it, and I know I don't know enough yet to handle that. What else can we do with the type system? Mutable composite types. We got declared type, type unions. Yeah, I think this. I don't see. Is there anything else without going too deep that I care about? Type selectors. Yeah, it's good enough. I think I got enough about types. Although, okay, here we go. So I guess this is. I'll take that back. So custom printing. There we go. So I guess I should put some documentation because it's going. It is telling me that I was failing, right? And I guess I should read the documentation. So often one wants to customize how types are displayed. So here we go. And we have this example. This is accomplished by overloading the show function. Well, so maybe I should quit being, weak here, and I should just show their example. Let's do that. So let's go here. Let's say struct polar. Okay. And then the next thing that I'm going to do is I'm going to instantiate it. Right, so let's go ahead and run it. But what did I not float? Did I? Oh, I didn't comment this out. There we go. Let's clear this. Okay, so we got this thing. Well, I'm not doing anything with it yet. So the next thing to do. So here we've added a custom constructor, so it can take arguments. If you want to display this, we would need to define the method to print the object given an object, an output. So I am kind of curious if it's smart enough to figure this out, because, and let's see here. So base show. So in this case, we don't want to do this, right? We actually don't want to do this. We want to say custom print function for polar. We want to do. Ooh, look at this. So what is it giving me? So it's giving me this. Let's see what it does. So is that what I needed? Z polar, that looks good. So it was close. It gave me a little bit, and the difference is that it uses IO here. It does now Z plus R. See, I don't know what this is doing. This is confusing to me because I don't see the R here. Where's the R coming from? Z dot R. Where's R? I don't see it. Okay, I guess R just is magic. But for now, I'll ignore that. And then if I want to print it, I would just make an instance of it. Note that print. So we have this prints. Well, what happens? Yeah, let's just run this. Let's see what happens. And didn't do anything. So now, what if I just want to print polar? That's it. As a rule of thumb. So let's make an instance of polar. And let's see if this can do it. So we'll say now print polar instance. And sure, let's try that out. What does this do? No method matching polar. Well, because I think I screwed it up because first I need to make an instance and then I should print it out. Let's try that. No method matching polar. Then why did that 3 polar floats? Let me read through this documentation one more time here. So we create this. Next, according to this should just work. So let's first try this. Let's try that. Polar, does this work? Does anything work? Does that work? No method matching polar. How is that possible? Closest candidates are polar. Very interesting. No method. Then what is this thing? If it says no method matching polar. Struct. Oh, do I need to make... I need to actually... There's a comment by overloading show. We define a type to represent it. I see. Now we need to say polar. Now, where's promote coming from? Is promote here? So I guess this is the line maybe that I'm missing. Is you have to use that struct. So I have to do this. I have to call this line of code here. Let's try this. Let's try to break it down into pieces. Okay, so the code doesn't blow up. So that was what I was missing, was I define the struct and then I have to use it. And then I guess in this point, I'm instantiating it. But now if I said this, I'd say prints results of A, what happens? There you go. So yeah, kind of interesting. That I guess you define the struct, but first then you have to actually use it, then make an instance of it. So this is for some reason, I don't know why I need to have this much code when all I want to do is define something that is a certain type. I guess it's an upfront type declaration that I then use later. But it seems like a little bit of a weird convention. And then I have to overwrite it. This whole thing looks sloppy to me, but I also don't know what I'm doing. So that could be why. But interesting. So that was actually useful to do, and I'm thankful I had my AI assistant to help me out. So I'm going to check this in. So we'll go ahead and do that. Here we go. Adding types. So great. Learned more stuff. I feel a little bit better. So next week, I'm going to cover methods, which are similar to functions. And that'll actually be a lot of fun. All right. Thank you. I'll see you next week.